大家晚上好，欢迎来到今天的 Reactive App 休闲黑客松 Demo Day。非常高兴能和大家相聚在这里，一起见证本次黑客松的成果展示。无论你是开发者、评委老师还是社区的朋友，都非常感谢大家在百忙之中参与到今天的活动中来。今天我们将看到一系列充满创意与探索精神的项目，也希望大家在这个过程中能够有所收获、有所启发。接下来，我简单介绍一下本次的休闲黑客松。它和传统黑客松稍有不同，更强调轻量化运营、开源公共产品、去商业化、轻松参与、人人皆可获奖和精心策划的主题。在技术迅猛发展和商业浪潮的冲击下，传统黑客松中纯粹的探索精神、创造热情和自由氛围正在被弱化。于是，由良心道社区发起并维护的开源项目。开着 Hackathon 应运而生，它面向所有人开放，任何人都可以免费自由的参与。我们希望大家在这里能够回到最初做项目的状态，玩儿和探索，跳脱日常约束，尽情享受编程本身的乐趣与自由。因此，今天的 Demo Day 不仅仅是一次成果的展示，更是一次创意的交流、想法的碰撞以及探索过程的分享。可以说，每一位完成 Demo 的参与者本身就已经是赢家。接下来为大家简单介绍一下今天的整体流程。今天的活动主要包括3个部分：Project Demos 项目展示、Judging Panel 评委互动，还有 Prize Announcement 奖项公布。注意，今天公布的是奖项名称，具体的奖金获得要在3个工作日之内另行公布。接下来简单说明一下 demo 的展示规则。所有项目将按照提交顺序进行展示，每个项目有5分钟的展示时间。下面我为大家介绍今天的评委互动环节以及我们的评委老师。在本次 Demo Day 中，评委将进行实时反馈并评定奖项，同时所有参与者均可获得 NFT 徽章。今天我们非常荣幸地邀请到了2位评委老师，Evan，Reactive 开发者关系负责人和 Stan，Reactive 技术内容与开发者关系专家。We are very honored to have our judges with us today. First, Ivan, head of developer relations at Reactive, and also Stan, tech writer and developer at Reactive. Would you like to say a quick hello to everyone?
Yeah, hey guys, happy to be here with you today and looking forward to seeing your demos. Um, yeah, I believe we've already met on the bunch of previous workshops, so you know a bit about me. And Stan is my colleague who's responsible for all the docs that you've taken a look at, so that his work, and he is also an expert in Reactive smart contracts. So yeah, looking forward to what you've built on Reactive Network.
Okay, thank you so much for joining us today and welcome. 再次感谢2位评委老师的参与，欢迎你们。接下来我们进入大家非常关心的环节——奖励说明。所有奖项及发放细则将在 GitHub 平台同步更新。本次 Demo Day 主要展示的是 Web Coding 赛道，将评选出3个获奖团队。1等奖获得的奖励是3万个 React 代币，2等奖是2万个 React 代币。Sorry。哦，对的，2万个 React 代币，3等奖是1万个 React 代币。需要说明的是，本次获奖名单将在赛后由内部统一评估与确认，预计在3个工作日内完成。后续我们会在公众号及社群中统一公布结果，并联系获奖团队提供钱包地址，用于奖励的发放。此外，还有专项挑战赛道，参与方式为完成 Reactive Network Demo 仓库中的任意3个 Demo 的部署与运行。该赛道共计3万个 React 代币，将平均分配给所有完成任务的参与者。同时，所有完成 Demo 的团队都将获得良心道开着 Hackathon NFT。那接下来我们就正式进入 Demo 环节。Now let's get started with our project demos. Judges, the demo session is starting now. 那接下来就是我们的第一个项目 K Market，欢迎团队开始展示。
Okay. Oh, hello everyone. Can you hear me? Hello.
Yeah, yep.
Okay. Let me share my screen. Okay. Let's first introduce myself and hello everyone. And this is the Kimaki team. And Draken. And Kimaki is the high frequency, the focus and market based on the key line. So and the second, please watching the demo video of our project first. Okay. Just wait a minute. And can you hear the video sounds?
No.
Oh, sorry. Just
Through and
and
logic.
now?
I've already connected my wallet. The core features of our platform are range prediction, dynamic odds, and zero liquidation risk. So now let's go enter the market. As you can see, we support a wide variety of prediction markets, not just near one, near two, not just crypto tokens, but also politics and sports. Let's say Bitcoin for this demo. We enter the market, you will see a lot of great. You can make a prediction like this. Based on the price range on the left, and it will settle according to the real-time price. You can zoom and it out of the grid, and on the right side, you can choose your deposit amount. This is the core functionality of our product. It's like this. Interesting. And the next is a seeds board, where we can handle deposits and withdrawals.
Let's take a look at our top-up module. Now we click top-up, then we top up to USDC. We are on the Arbitrum testnet. Click start. Okay, we can see our transaction has been on-chain. We can see the transaction hash and the transaction data here. It's on the Arbitrum testnet, including the logs. The transaction was successful. Next, we click on this cross-chain top-up transaction to view the top-up record. We can see that this is the top-up operation we just initiated, and the corresponding receipt record has been synchronized. The funds have been successfully credited to our PLL testnet. From the interface, we can clearly see that the top-up amount has been added to our treasury account. This is our complete cross-chain top-up workflow. In terms of technical implementation, we use Reactive Network RN as the cross-chain automation coordination layer. The RN chain monitors top-up events on the Arbitrum chain in real time. Once a user's top-up transaction is detected, the system automatically triggers the callback logic and directly updates the treasury ledger on the Polygon chain to finalize fund confirmation. The entire process requires no manual intervention and is fully automated on-chain, making it secure, efficient, and reliable. The withdrawal function is currently under development.
Okay, this is my first highlight, and the second highlight is the design of the multiple lead. And we So we decided the reactive liquid energy. So I will change. Okay. Liquidity port is my rebalancing and current key market configuration. There is the LP pool use the cover any short files improve the reactive in voltage. Reactive intelligence point mounting the liquid level of the LP pool in the wall. If the LP pool's fund drop to the dangerous level, like less 10% due to payouts, the reactive contract automatically triggered a flash load withdrawal from the RV or the compound, transferring the interest-bearing the USDC back to the key market wall to the replenishing the liquidity. When there are excessive idle funds, they are automatically transfer the defined petrol to the of the interest. We can see the process flows like this. And complete the function flows like this. And user transition beyond event can key market wall to emit event to reactive contract, listen and judge, and trigger the schedule the defined petrol and like RV and the compound. Yeah, that's all.
So the next one will lead from Patrick.
Okay. I will help the Patrick to introduce his project. He have something to come up, and I'm not the member of his project. Okay. Let me show the deck. Can you see my screen?
Yeah, clearly.
Okay. Hello everyone. Today I'd like to introduce Wallet, a reactive native wallet prototype. Its core idea is simple: define an intent once and let the wallet execute later when the right on-chain event arrives. This project wants to save the problem. The project starts from a clear problem. Most wallets today are still session bound. The user clicks once and the wallet acts once. That model is limited when a wallet needs to keep responding to external on-chain events over time. So Wallet propose a different wallet model. A wallet should not only store keys and balance, but also intend runtime state and execution logic. That means the wallet can keep acting even when the front end is no longer open. Next, I will introduce the architecture. The architecture is simple. Origin eventing autonomous wallet execution out. The user thinks once and saves an intent. Then a reactive contract listens from a valid event, rotates a callback, and the wallet validates and executes the action. So this is the proof of execution. This is not just a concept. The deck shows three valid end-to-end execution paths that already live. So the project also has real proof, not just an idea on slides. It's also an strongest advance. The strongest advance is that Wallet reacts to real external protocol events. For example, a real Uniswap superior swap can trigger a wallet funded action. So this is not just a fake demo event. It's reacting to real on-chain active. this part answers the question why active network is essential. Without negative essential, this would fall back to a normal off-chain bot model. But there, the event listening and callback routing are built into the reactive follow. That's why this not just about valid automation, but a valid designed around event drive execution. So what users actually get from the user's side, the setup only happens once. The user connects a valid store and intent and funds execution when needed. After that, the wallet can keep waiting, validating, and execution later on its own. And next, where lead is bigger than one demo wallet. The next step for the well lead is not just adding more demo feature. The focus is on holding the architecture, including multi-tenant wallets, more leaf protocol template, stronger keeper infrastructure, and cross-chain execution. Yeah, this one. So to conclude, Wallet asks one simple question. If user define intent once, why should the wallet stop acting? Why the front end disappears? This project shows that intent can become wallet state and real protocol event can trigger wallet behavior directly. And next I will show the demo. Okay. Can you see the video?
Yep.
Okay.
Is there like I didn't hear any voice from the video?
Okay. Mm-hmm.
Reactive 的主要说明，它就是去接听一个 Uniswap 的池子，就是以太坊兑换 USDC 的池子，但是它同时接听了4个池子，也就是说，如果只要接听到在这个4个池子里面有交易的话，它就会去执行这个动作，也就是说，它会往Reactive 的那个合约里面去打 ETH，然后去兑换它的 Reactive 测试网。然后我们可以在这里保存计划，保存计划的话，它就会开始往那个去注册窃听，这里我们是要进行签名的。然后我们稍微等待一下。可以看到它已经是注册完成了。然后注册完成的话，我们可以看一下我们现在的那个自助接见钱包里面的以太坊是0.5个，然后可以看一下， 我们的 Reactive 测试币是214个。然后我们注册完切钉之后，我们其实可以直接让这个切端去理性的，然后我们可以在这里进行，这是我们接新的池子进行兑换，就是 ETH 兑换 USDC。然后交易完毕的话，它的计划应该是已经被接听到的，被接听到的话，它应该就会去执行我们的 callback 回调函数。我们稍微等待一下，这里目前还是214的，也就是说它是完成了一个闭环的，也就是说前一端它能离线，然后只要接，然后去执行你的目标策略。我的演讲就到这里差不多结束了。
Okay, that's all for this project. I hope you could understand his project. That's all. Thank you.
下一个是 Ploy VIS。
Hello. Uh, Hello everyone. Can you see my screen here?
可以的。
Okay. So let me first introduce some basic knowledge about my project. This is a poly signal. The poly market were alerted by the reactive smart contract. So it's here we list some basic about the architecture abstract trust minimize on-chain paradigm for the market anomaly detection. So that you can view it as a tool to monitor the poly market signal, and it offers some trading alpha tools for your poly market trading. So here is my structure of my project. We use some backend in the Web2, and we use the core contract in the reactive network as our mechanisms. So we use some smart contract to detect the anomaly rules entirely on chain. And the solution here, we use some cross environment and verifiable from the smart contract code only alone. And the events natively trigger the destination transactions without human or centralized server integration. So here I list my pipeline and how does it work. First, we need to monitor some order field and market on the point market, like the wheel, like some nominal tradings on the market. So and the trading will relate to the original smart contract. And next, I use my deployed separately original smart contract to judge whether I can trade now, like receive some related summary emis and trade single observed event. To make the second step is like the reactive network evaluation. I use my polysignal reactive network to subgress to the exact event and evidence the anomaly rules on chain to judge that whether reactive callback if the thresholds are met. And the final step, I use my separate destination smart contract to do my trade or to see my final alpha. Okay, and here I list some of the smart contract knowledge here, like the orange signal on the orange smart contract Sepolia, and the core reactive smart contract and destination. Or here I list some framework of my project. Like we have the executable context, the evidence on chain, and the third step is we can get some alpha feed of the part market by this smart contract. And the final step is that we can use this type of anomaly detection to make the market trading. So next I will show some basic usage of this step. Okay. So this is front end of our project. like is the on-chain trading signals of and the subscription flow of the poly market. And the first step you must connect the wallet like the MetaMask use on the Sepolia test network or the Reactive test network to do the basic connection. And the next step is the runtime status. Like it shows live, it means like we connect the poly market on the Polygon chain. We get the data successfully, and here we list some of the evidence of our project. Like the Polygon first step is Polygon trading, and relate the Polygon trading knowledge of information to our Somnia Alpha and native reactive callback is the fourth step, and the final step is alpha signal output. Like it means that if the on-chain solution are met and the reactive contract emits the alpha signal, and you can see the alpha is the front end. Here I did some basic the real usage. Like this is a market, and we found that there are eight alpha possible tradings in now, and we can follow the trade and we can bet on the poly market. You can view the market by this market link. Okay, and if you unlock the typically you must unlock the alpha signal here by your MetaMask, but I linked my MetaMask before, so you can view the all the knowledge here, like why this market is allowed and why this is an alpha signal. Like we have some more example of the alpha tradings, and you can bet on the poly market based on this trading and know yourselves. Okay, here we list some examples. Okay, so this is our project, and if there are any questions, just ask me, or you can view my GitHub repos.
我们的下一组是 Echo Capsule，有请我们的
等我更
团队来进行展示。
跟我共享一下。
Hello, esteemed judges. I am Su Sheng. Today I want to discuss fan culture, or fan economy. Have you ever wondered? In this era, fans spend hours daily supporting voting on chart, paying to leave comments. But where does this warm affection ultimately go? It becomes cold numbers. In TikTok's financial report, traffic. These metrics are all locked in centralized platforms' black boxes. If platforms ban accounts on a whim, years of fan support vanish instantly. Idols would never know, behind the screens, who their most devoted fans truly were. Fans pour genuine emotion, yet can't even obtain proof of their support journey. This is essentially hidden exploitation. Then came Web3 and NFTs. We thought it solved things, but it didn't. Most fan NFTs are just speculative, lifeless, static images. They completely miss emotional resonance. Imagine, when a fan spends 1 ETH to leave a caring comment, remember to rest. How should we automatically reward this loyal fan with points? Current solutions still involve building new black box, writing centralized server scripts to monitor the platform, then manually distribute rewards. If the script crashes, fans' love gets stuck forever. This isn't true Web3. So we created Echo Capture. Please watch the demo. Let me log in. Please watch. This isn't a dead image. It's alive. Now, the core feature, emotion sync. When the idol is in the management backend, switching today's mood to exhaustion mode, toggle to fatigue setting. Without any platform notifications, fans owning this capsule are instantly recognized across platforms. Their dynamic interactions create immediate resonance. Even the background color transforms. The BGM automatically switches too. Now initiating the on-chain process. See? The idle interface has. Let's switch to the fan interface now. Now we're on the fan side. Fans can not only sense the idle's mood, but also click deep resonances to engrave their messages with real assets permanently on the blockchain. As tribute to their idol, this transcends screen boundaries. A genuine two-way connection between them, with no middlemen taking cuts. But as mentioned earlier, the real challenge was automating rewards for paying fans without centralized servers. This is precisely where our project shines brightest and why we chose Negative Network. We've transformed fan idle interactions into a fully on-chain, self-executing pipeline. Observe these 3 steps. 1. Fan pays on Sepolia chain. Host's message triggers Reactive. Reactive, instantly detected by Rui Ying's smart contract, which autonomously processes the message, calculates exact loyalty points on after completing the feedback loop, directly triggers the spoil chain, issuing superfan badges to devotees, and points to fans. Let's return to the idle interface. Eco Capture isn't just another dApp. It's proof we use UP Coding's frontend to deliver ultimate emotional experiences for. Meanwhile, we use a negative network to smash the centralized black box, automating trust on-chain. In this digital era, we return our emotions and all value back to fans. This is Echo Capsule. Now, watch this. These 3 consecutive transactions at the bottom. This is the irrefutable proof of those no servers, no script, only immutable code. Guarding this sentiment for the fans.
That's all. 谢谢大家。
我们的下一个项目是 YC Hack Reactive Stop Order MVP。
Alright, can you guys all hear me right now?
Yes.
Alright, let me just share my screen and see, can you guys see the audios? So you guys can just like stop me if you guys couldn't hear sound, and let's get started.
Hello everyone, this is YC from YC Hack.
Can you guys all hear it?
Reactive
It's like a bit small.
Access. We build a live demonstration on Sepolia and Reactive Network to show that market event can automatically trigger an on-chain execution flow instead of relying on manual monitoring or private bot. The core problem is that smart contracts are isolated from the environment they need to react to. In practice, most stop-loss system still depends on centralized keeper or off-chain bot, which create delay, operational overhead, and trust assumption. Our thesis is that access should become naively responsive. Instead of pulling off-chain and then decide what to do, we use Reactive Network to turn live on-chain event into event-driven execution paths with verifiable proof. The architecture is simple. On the left, we observe that Uniswap V2 pairs, and on the middle, a reactive VM listen for the pair sync event and evaluate the threshold. On the right, it's just a callback contract on Sepolia perform the actual stop-loss executions. The order of pipeline has 4 stages: created, monitoring, triggered, and executed. Once the order is created, we deploy an order-specific reactive contract. Let it monitor the pair, detect for qualifying reserve movement, and then push execution into the callback contract. What this makes it useful is to judge for the visibilities. We do not just claim automatically happened, we collect the proof trails across the pair updated, the reactive trigger, and the callback executions. So the final result is visible and verifiable. So now let's come to our demos. Here, just come to my quick demo for our project. So let's get into a workflow. So on the home screen, here it's like a general overview for you to see what this project is about and how we're going to execute it. And this one is like how we're going to monitor for the pools. There's like 2 type tokens, and then here just like the wallet we use for each token to do the test. And then here, just like the execution step, we're going to do follows in our dashboard. So now come to our dashboard, we can see that all the live boards have been set already, and now we can just like start creating our orders. So before creating the order, we have to make sure we have enough of like approval coverage. And now it's like 3 out of 2 following like this order amount, so it should be enough. And we got some of the reactive balance, so it should all work as well. So now, if it's not enough, we can just like do from here and here to add some of the value we want. And here, now come to approve orders. So after we press it connected, it's going to run on the back end, and it's going to take a while because it's going to interact on chain and then go through some of my script at the back end. So after I'm created, we can see like how we done for here. It has been changed to created, and the state is ready for reactive auto deployed. So here we just like follow like what we want, or this one is just like default value, so we can test it really quickly. So after we confirm the actions, again here is like interaction with backend, so we're going to run for a bit. So this one is just like we are trying to monitor like what or like will change in the real life. So each order is being created, and we can see like when there's like some event on pool happened, we're gonna see how will our contract react by itself. And if it's on real world, everything will be automatically, but now we're just like focusing on one contract, so that's why we have to manually do it. Yep. And after that, after I finish execute, everything we can show from here, it can be executed and executed. And then we can see from here, allow coverage, initially it's like 3 out of 2, but now become 1 over 2 because what we do for order amount is like 2. So here, it's just like a basic showcase of how we did. And here, you have like all of the track of how we have before. Like order 22 is what we just did, and this one is executed successfully. And we can also check from here, and now you can see the value changes. The post condition have been changed, and then here it also got update as well.
Yep, and that's basically my demo video, and like, cause like, from what I just did, so I'm just here to showcase some of the result that is actually happening. So in the demo that we just showed about, and this one is just like the on-chain history you guys can all view about. It's like I created this one like 19 hours ago, and here just like some transaction action happened on-chain. And then yeah, and then what I mentioned about this part, the allow coverage is basically just a signature. So initially we need to have like enough for our order. So if our order amount is like 1, then he'll be showing 1, and then here if it's 2, then he'll be respond by itself. And then this one just a quick showcase. Like on chain, we still need to like sign in to do the sign, and after we do that and wait for a bit, everything should all run successfully after the signatures. It just like I might to like like this one. So this is what I just mentioned about some prereq for this project to be able to execute. And this concludes my presentations. Thank you for listening.
感谢刚刚精彩的项目展示。我们的下一组是Protoma Yatize， 请开始你们的展示。
Let me share my screen. So can you see my screen now?
Yes.
My slides. Okay. Hi everyone. I'm Swing, as you know, and this is Protomo Yachts. I know at first glance it looks like a piece of art boss battle game, and that part is real. It is an on-chain roguelite-like battler built around fast playable combat. But what we really want to show today is not just the game surface. We want to show the system behind it. Optimistic gameplay, verifiable term settlement, and automatical cross-chain rewards. So this is not just a game demo. It's a demo of how a battle outcome can become a real on-chain workflow. And this project is already live at Verso, as I think you can see the link on the slide. Nowadays, the problem we are targeting is what we call the broken chain of rewards. In Web3, at least I suppose, in turn-based games, players want fast, local responsiveness. They want a game to feel immediate. But at the same time, settlement still needs to be verifiable on-chain. And after player wins, rewards should move automatically across contracts or networks. In many systems, that last step still depends on backend watchers, manual replayers, or Web2 style services. And once that happens, the reward path becomes harder to operate, easier to break, and less trust minimized. So the real gap is not just gameplay. It is the missing link between fast battle, on-chain trust, and automatical rewards. This leads to the core question of Protomoyas. Can a game victory become a real on-chain workflow? More specifically, can we keep gameplay fast, keep settlement trustful, and still move rewards automatically without adding a separate backend watcher, without manual coordination, and without reintroducing actual trust? Bingo. That's what we are doing. And the key is reactive. In the future, a game event is no longer just something that stays inside the game. It becomes something that can drive real on-chain execution. This is why we say reactive is the engine, not an element. Let me show you the demo video now. Oh. Can you see my video?
No.
How about it? How about now?
Maybe you need to quit sharing and try it one more time.
Okay. Let me do another share. So, can you see now?
Yep.
Oh, okay. Here's the our entire workflow. I played it. To be honest, I took nearly 4 hours to pass the first boss, so it's like a nightmare. First, on chain, on origin, the winning term is settled, and the contract emits game one. Second, on reactive, that event is picked up and rotates through the reaction logic automatically. Actually, you need to be familiar with the elements and the spells, and need to remember your dice number, user logic to win this game. Actually, I think it's not easy. I think I'm gonna. Yeah, I got a yes. So I think you will forgive me to take a screenshot. Third, on destination. No, it's not destination, but I think I'm gonna win because I got a yes. I'm really lucky though. I think so. Tragic. Every skill you used, you will never use it another time. So you need to use a strategy to keep the game moving and to beat the enemy. Yeah, it's dying. Yeah. Third, on destination, the callback completes and the reward is recorded as batch minted. So this is not manual. It's not webhook based. It's not simulated, and it's not a separate off-chain watcher doing the real work. Reactive is the part that turns the game win into autonomous downstream execution, and um, I think I can close the video and back to our slides again. You can see my slides now. Can you see my slides now?
Yes.
Or I need to close it again. I'm sorry.
Yeah, we can see your slide.
Okay. Thank you. And at the bottom of this slide, we show a confirmed proof trail. Start game to game one to reactive transaction and to batch minted. That is the most important thing in this demo. Not just the battle looks good, but the workflow actually run end to end. So to close, Proton YAS proves a very specific pattern. A game event can become a real reactive on-chain workflow. For us, this is the main result of this project. We did not just build a boss battle. We connected trustless mechanics, optimistic gameplay, and reactive execution into one working loop. And looking forward, pattern is not limited to human players. Surprise. It can also support agent or machine gameplay in the future, which makes this workflow relevant beyond games themselves. I'm Swing, focused on smart contracts and reactive workflow, and my braining teammate Davey focuses on beautiful design and full stack. Thank you. Thank you for listening.
Oh, well centered. Well centered.
Yeah, it's me. Okay, let me share my screen. Can you see my screen? Okay, let's start it. Wait. Okay. So let's start. In crypto, whale activity can affect the market very quickly, but most cross-chain reactions still depend on centralized votes. That means the process is slow, centralized, and hard to verify on-chain. So we built a smart whale sentinel. It's a reactive cross-chain system that take a whale event on the original chain, a reactive network listen to it, and then automatically triggers execution on the destination chain. So the workflow is very simple. First, the original contract emits a whale event. Then the reactive contract listen to that event and send a callback. After that, the destination contracts receive the callback, store the whale data, and update the strategy state. So the whole project is really about turning an on-chain signal to an on-chain response. On the front end, we keep the demo very simple. The user triggers the whale event, and then we show the original transaction, the destination transaction, and the final strategy result. So the front end is mainly to make the whole reactive flow easy to understand. Technically, the system has 3 layers. The original layer emits the whale signal. The reactive layer subscribes that signal and validates it and relays it across chains. The destination layer receives the callback, stores the whale data, and executes the strategy logic. This is the key technical idea of our project. We do not rely on a centralized bot to watch the events and relay them. The event itself becomes the trigger, and the response is handled through the reactive contract flow. And the main difference is that we remove the off-chain relay from the critical path. Instead of using a backend bot to monitor and send the follow-up transaction, we use a reactive network to make the flow more automatically and more traceable. So next, I will show the demo video, and I will share my screen.
First, this is our homepage. Here, we present the core features of the project, the main pain points in current cross-chain monitoring, and how our solution improves that process. Now we move to the demo page. This is where we show the full reactive workflow in action. In step 1, we first connect the wallet. Then we simulate a whale transaction on the origin chain. Once the wallet is connected, we click this button to trigger the full flow. This action calls our deployed origin contract and emits an event on the source chain. Right after that, we can see the origin transaction. We can also open the Block Explorer and verify that the transaction has been successfully confirmed on chain. After the origin event is emitted, the system moves to the next stage. Now Reactive Network listens to the event and prepares the callback to the destination chain. Now the result is available. We can see that the destination transaction has been successfully produced, which means the reactive callback flow is working end-to-end. Then we move to step 4. This step is about interpreting the whale data recorded on the destination chain and deciding what strategy the system should take. Decide whether the system should follow, protect, pause, or continue observing. So these 4 strategies represent different ways the system can react to whale behavior on chain. They are the decision layer of our demo. Now we can see that the destination logs and execution results are complete. That means the full workflow has successfully run from start to finish. So the complete process is simple. An event is emitted on the origin chain. Reactive Network completes the callback, and the destination chain executes the final strategy logic. This is the key value of our project. We replace centralized monitoring and relaying with a more transparent, automated, and verifiable reactive cross-chain flow.
Okay, back to our PowerPoint. And the last one, so in the future, we want to connect a real whale data instead of just owning mock events, support richer strategy logic, and improve the execution layer on the destination side. So we hope this can grow into a usable reactive automation framework for more on-chain finance use cases.
Nala 有请我们的团队来进行展示。
Hello everyone, my demo is called Nola. What it does is simple: detect once, defend across chains. Nola is a cross-chain approval firewall for safe smart wallets powered by Reactive Network. In this demo, I will cover 3 parts: why we need Nola, why we choose Nola, and how Nola works. Well, if you have used Web3 or DeFi, you know how common approvals are and how risky they can be. There are 3 major partners. First, over approval. Many contracts, even the safe ones, ask users to grant unlimited allowance. For example, Uniswap does this to improve user experience. So you might only need 10 USDT, but end up approving unlimited access. Second, revocation is hard. Users approve quickly, but rarely clean up later, because approving is easy but revoking is not. It's done the skill for individuals and definitely not for teams. Third, cross-chain risk. Wallets like MetaMask use the same address across all EVM chains, so if one chain is compromised, all chain is dangerous. It's not good for safe. Nola solves this with one unified workflow. Detect risky approval across chains, revoke on the source chain, activate shard mode on peer chains, and recover automatically. Here is how it works. A single reactive contract listens across chains like Ethereum, Sepolia, and Base Sepolia. When a risky approval is detected, it triggers coordinated defense actions across chains. In this architecture, Safe Smart Wallet is the execution layer, and Reactive is the coordination layer. Now let's compare Nola with the existing solutions. Tools like Revoke.cash are great for manual cleanup, but they react too late. The same modules and guard is great at local control, but Nola is the missing cross-chain layer. And automation tools like Chainlink or Gelato are powerful, but they are designed for different problems, like periodic test or off-chain logic. So Nola is different. It is event-driven, on-chain, and cross-chain by design. This section is a bit short because of 5-minute restriction, so you can read the point later. But Nola Using the reactive network is the best and the only one solution in this cross-chain circumstance without off-chain facility. Okay, now let's go to how NOLA works. Okay, NOLA is a cross-chain firewall. First, you need to go to the onboarding board and set your wallet into the Guardian mode. And it's already set. Then you can go to the security console. And we can run a risk approval. Okay, the transaction out, and we can go to the security console. You can see the both Sepolia in the short mode immediately, and the Ethereum Sepolia approval set to 0. And now it have a countdown. It's mainly exist, and the laser block, laser tick, and you can exit the short mode manually. So the countdown, I set it about 12 minutes. So I can exit it manually. Okay, it exited successfully. For the other chain, it is the same. It's a crossing firewall. So you can run this risk or run this system. It's the same. So that's all.
我们下一个项目是 Reactive Flow，有请我们的团队开始进行他们的展示。
那我这边就直接用中文了。然后我这边的项目名字是 Reactive Flow，然后它是一个跨链的一个自动化的一个工作流的一个编排的这样一个应用。然后我们要解决的一个问题就是传统的那个跨链的自动化的它的一个流程，它是需要一个离线的一个 keeper 服务或者是定时任务，然后需要去监听链上的一个事件去执行，还需要中心化的一个 relay 的一个 server，然后它容易出现单点的一个故障，然后我们需要信任所有人，然后需要复杂的低位 ops 的一个流程，然后我们需要的一个就是全链的一个执行，然后不需要额外的一个依赖，然后可信的，然后没有服务器，然后不需要代码就能够配置。然后 React Flow 它就是一个 low code 的一个平台，用来做跨链的一个自动化的一个 flow，然后它支持 Reactive 的所有的网络，然后它全部在链上，然后它不需要代码就能够去构建自己的一个 workflow。然后只需要通过一些步骤的一些配置，然后就能够生成一个 flow。然后它整体的一个架构是它的合约分为 factory， 有一个用来注册的一个工厂，然后你的origin 可以是用户的一个任意的一个合约，然后 reactive 这一层有一个 flow 的一个引擎用来订阅一些事件并且执行。然后，这个目标合约可以监听那个事件再去执行。这个就是整体的一个流程，用户去在那个平台上去创建一个 flow，然后会部署2个合约，然后监听一些事件，然后就根据事件里面配置的一些回调，然后去进行一个执行。然后。合约的话有2个，一个是 flow 的一个 registry，用来注册所有的一个 flow，就是保存用户 的所有的一个 flow。另外就是那个核心的一个 flow 的一个引擎里面会去判断用户的那个订阅的那些事件，进行一些条件的一些判断，然后去执行发射出对应的回调。然后就是，core 合约里面，有一些那个操作可以进行一些比较嘛，比如说 transfer 的时候可以监听一些大额的一些转账什么的，会内置了很多的那种操作服。然后整个的一个前端就分为4步，触发，然后触发的一个合约的一个配置，然后以及一些条件的一些设置，以及你要对应执行的一些操作，然后最后就是进行一个部署。然后大概就是这2步，然后里面内置了一些模板啊，我想的是一些，这些都是目前的一些简单的一些实现。另外，比如说高级的一些实现的话，就是可以跟监听 Uniswap 上的一些大额的一些转账，然后你可以进行自己的一些卖出，然后还有就是一些，呃。定时任务，比如说你要进行一些 DCA 啊，或者是定投这种，还有比如说监听 NFT 合约的一个 mint 的一个事件，然后去自动的执行一个 mint，这些都是可以根据这个流程去配置出来的。然后技术站的话，这个就不再多说了，我们等一下演示一下 demo。后面的我能看到这个界面吗？
可以看到。
然后我就用这个来演示一下整个的一个流程。然后我创建一个新的一个 flow 合约，然后我们来测试一个转账的一个，然后我先找一下那个地址。
我们演示的时候尽量加速一点，现在已经
嗯，
4分半了。
好的。设置超过1000的时候，然后就到这个 flow 里面，这个执行历史有一点小问题，大概的流程，创建 flow 的一个流程就是这个样子。然后的话，我要去另外一个钱包进行一个转账。这个的话有一点点的延迟，这里会出现会晚一点，就是大概的一个流程，就是转账成功之后，这里的一个事件会出现在这个地方，然后这就是我的一个那个应用的一个演示，这里它等一会儿会刷新这个历史记录，然后我的演示就到这里，谢谢大家，这里需要
好的，
再等一下，可能需要一点时间，然后有什么问题可以问吗？
好的，感谢刚刚精彩的分享。Judges, are there any questions?
No, probably not. So the idea looks really useful. We'll take a look at the code and evaluate based on that. Thank you very much for the demo.
好的，感谢我们评委老师以及刚才的演示，然后我们就进行到下一组。我们
这里
的下一组
能看到那个结果了。好的，谢谢。
好的，谢谢。我们的下一组是 using RC for on-chain automated liquidation and arbitrage，请开始你们的演示。
好的，我这个项目的话，主要是一个链上清算和那个跨链条例，主要是这两部分。第一部分呢是一个那个链上自动清算的一个功能，主要是这个，比如说这个 ETH 价格下跌的话，会有这个健康因子，然后判断它小于一的话，会触发我们这个Reactive 上面的一个监听事件，然后呢自动会执行一个清算。一样结果的话，就是清算由链上的价格进行触发，然后 RC 的话自动执行，不需要人工去干预。前端活动的话，会有一个完整的日志展示，方便追溯。第二个功能的话，是一个跨链套利的一个功能，主要的话是在一个链卖出这个 ETH 的话，换取这个 USDC， 然后在另一个链的话，可以用这个 USDC 买入这个 ETH， 然后由这个 RC 进行协调，进行一个价差的捕获。然后验证的话，就是双端交易均成功，然后成功捕捉到这个正的这个价差。然后前端活动的话，也是有一个这个完整的这个日志捕捉在里面。然后我们这个项目的话，主要的话是用这个 RC 来做，然后传统方案的话就是那个纯链下的脚本，功能比较单一，然后仅限开发者使用，执行也不透明。然后用我们这个Reactive 的方案的话，这个话是事件驱动的一个逻辑，风险和收益是基于一体的，然后面向所有人的产品，然后活动日志和完整的这个链上可追溯性。然后 Reactive 的话就是完全的去中心化，没有这个暴露密钥的风险和全天候的这个运行，几乎没有这个运营的成本，这是我们这个 Reactive 的一个优势。然后呢，我下面演示一下这个产品，看一下。然后呢，这块的话就是说刚进来的话是一个清算的介绍页面，然后呢，中途的话都是做一些这个模拟数据进行测试的。然后呢，这块的话开始我们会先让用户进入一个存款之后呢，每个用户是可以部署自己的一个 RC 的一个监控的。然后第3步的话就是开始运行，这是一共3个步骤。然后这边的话是一个事件日志的一个捕捉，然后之前的话这个视频的话就是在本地模拟的一些数据，然后呢改变链上的一个健康度，就会这个日志的话就会记录下来进行一个套利。然后这边的话是这个上面的话是跨链套利，然后下面的话是那个清算套利，这是两个结果。然后呢这边的话这个这边有个策略，我现在就是临时点不出来了，就是可以调整自己的一个触发的参数之类的。这些，然后可以调自己的分工参数以及这个清算参数。
进行到下一组，我们的下一组是 Reactive Vault Sentinel，请开始项目的演示。
Hello，能听到吗？
可以的。
就是我用中文来讲，英文不太好。然后，说一下我的项目就是 Reactive Want Sentimental 嘛。然后，这是我的项目的简介，就是它是一个跨链的自动化风控项目。然后的话，它主要是通过在原链就是监控风险信号，然后在这个 Reactive Network 上预设容忍，然后在这个最终在这个目标链上来实行那个保护性的操作。这是一个整体的框架。然后它预备的就是像是这个是它的部署合约，在这个原链，然后这个是 Reactive 层，这个是执行链上。我这个用的是那个测试网的，在用的是测试网的那个来实现这个的。 然后它主要有3个场景。第一个场景就是说它，比如说受到那个没有授权的wallet 流出的时候，就是比如说流出了2.5个，被黑客攻击了，然后或者重入攻击了，然后流出，这时候你这个你可以设置几个设置，然后它就会检测到来立刻卖出剩余的资产，转移到这个其他链上去，来保证自己的资产不受这个保护自己的资产嘛，或者减少损失。第二个就是，呃，比如说出现一种那个稳定币抛锚的情况，然后它会把稳定币兑换成其他的币种，也是减少损失的。第三个就是，这种。它就会自动通过 AAVE 这个识别器嘛，它会，比如说你在上面质押了一些东西，然后因为币价下跌达到一个清算值，它会提前你提前到你可以设定一个阈值，然后在它的清算之前，你把其他资产转进去来实现这个保护资产的一个功能或者卖出。然后接下来的话，我简单演示一下，这是我的这个前端的框架。嗯。等一下，喂，然后这是那个整体的一个框架，可以在这里看到，呃，它是这个的页面，就是哎这个是总体现在有5个 ruler，然后它这个剩下的就是一些什么overwhelm 之类的，然后这个是现在活跃的 ruler，然后这个是直播流的，它之前触发过的一次。然后我看一下这个 ruler，对，在 ruler 这儿你可以直接去配置嘛，这也是可以配置它的一个规则。然后我们现在创建一个新的规则，比如就是从原链或者是可以有2个嘛，一个是以太坊测试网，一个是 baseline 测试网，然后选择原生的代币，直接选择以太坊。比如说假设它呃这个是 P 价小于 P 价大于或者是流出多少。在这里设置它，假设它小于2000嘛，然后设置这个执行，这个执行这里还有其他的功能还没有加上去啊，因为暂时做的有些匆忙，然后可以部署一下这个 simulation，在这里部署成功，你就可以看到下面就是我部署的一些规则，这里可以配置，然后可以停止，可以这个启动，然后也可以删除这个，比如说我们删除这个规则就被删除掉了。然后现在只有5个，然后下面这个是它的一个整个的生命周期，就是说它会从原链出去，然后从一个Reactive 上面，然后再去这个 baseline 上面去执行。然后因为我现在碰见一些就是这个测试网上面有一些呃这个阻塞的问题，好像这个没有实现，不是这个暂时还不行。之前测试是可以的，对，几天前的测试是可以的。对，我现在可能会修一下这个，因为这个是触发了但还是没有那个，这个刚刚触发的，但是没有接收到。前几天触发是可以的，这个我会看一下，有可能是阻塞的问题，因为前几天好像这个Reactive 的那个测试链上也触发，也那个阻塞了一会儿。嗯，这就是我的那个这个项目了。
好的。大家好，我们的项目叫 Agents AI Garden，它解决的问题是很直接，就是说 DeFi 协议在遭遇异常流动性变化 （MEV） 或者说是潜在攻击时，传统告警只能告诉你出现了什么问题，但是你不能自动防御。然后我做的一套是由前端、后端 AI 到智能合约的完整闭环系统，让风险被发现后能够直接触发链上的防御动作。也就是说，现在目前很多的 Web3 安全产品，它只能做到监控和告警，但是真正的问题是，攻击不是按分钟发生的，而是按区块发生的。如果说团队还要等人看 dashboard，判断风险，再手动暂停协议，往往是来不及的。所以我们的核心价值就是把发现风险升级成发现后立即执行防御。我们的系统是一个闭环，也就是说前端连接钱包，并且调用后端 API，后端通过 Web3.py 监听合约事件，然后把事件送进 AI 风险检测模块，AI 算出风险分数后，再通过策略引擎决定继续观察、对冲还是直接暂停协议。 最后防御结果会重新写入合约和前端界面，所以用户能够实时看到风险分数的变化和协议状态的变化。技术上前端用的是 React 和 East.js， 负责前端连接、钱包连接和实时状态展现；后端是 Fast API 作为一个控制面平面，然后 Web3.py 负责读写智能合约和监听事件。链上有2个核心合约，一个是记录 AI 风险状态，一个是负责真正执行pass 这样的防御动作。然后这个项目最重要的是不是一个单个模型，而是一个闭环能力。我们不仅做一个静态的 dashboard， 也不是一个合约 demo， 我们是已经将钱包、前端、后端 AI 以及事件监听和链上执行结合到一块，而且整个框架是模块化的，后续可以继续扩展更多的风险类型以及更多的防御策略，甚至接入真实的协议场景。总结一下 Agents AI Garden 就是让 DeFi 协议从被动告警升级为主动防御，并且把 AI 风险判断直接转化成链上可执行的动作，并且实时反馈给用户界面。然后现在我来展示一下 demo。现在开始我们的 demo 展示，然后钱包处于连接状态，然后它现在的系统状态处于 safe 状态，也是安全，然后它的风险控制是离线状态，然后它现在目前它的风险指数是0%，然后我们进行连接钱包，然后现在开始模拟攻击，模拟攻击这步会用后端的对，后端会向已部署的合约写入一组异常的流动性数据，然后监听器接收到这个异常的事件后会触发 AI 引擎，AI 会计算风险分数，然后策略引擎会决定是否需要暂停协议，然后这里需要等待10到15秒。然后这里显示系统的状态变成 attack，然后它的风险控制变成 passed，也就是被终止，风险指数是55%。因为前端每3秒会轮选一次系统状态，所以你看到页面会从 safe 变为 attack，然后协议状态会从离线状态变成终止状态。然后这一部分就是可以看到你的风险指数是55%，然后可以看到你的控制地址以及你的交易哈希。这是它的工作流程。然后这里显示的是历史的模拟攻击的一些历史记录。举个例子，这是 OP 网上的一次闪电带攻击，然后点击就可以查看它的时间轴和它的 gas 消耗。如果在确认没有什么问题后，这里可以收回资金来进行保护，然后这里进行钱包确认。然后我的 demo 就分享到这里，谢谢大家。
在的，我在的，看得到我的屏幕吗？
可以看到。
好的。Okay, let's begin. The Wi-Fi means reactive intelligent connected infrastructure. It means AI can decide and reality execute. So if you remove AI and reality, Wi-Fi will die. And Wi-Fi have automatic trading agent on base. It's about 24 hours a day. And you can do anything you can ask, such as current ETH price and latest crypto news and market analysis. You can see he can know the crypto news and he can suggest you do something. And also I use the second key to make the AI can place start an order itself. You mean that the human doesn't need to approve. You can approve the agent to do something in your rules, such as $10 a day or $10 a time, and the AI just can grab that stop order or take profit order. You can see he can swap to the USDC to WETH. You can see it's about 10 seconds ago. And on the right, yes, trend. Also, we can talk to the AI to set a store load at 21,000 because it's higher than right now the price, so we will evaluate it immediately. The AI will suggest you not to do this because this thing is above the price, and you can just tell him just do it. And you can see he paid all the and he will active immediately because it's above the price and there is something swap on the unit swap will appear like this reality callback. So you don't you don't need to watch the dashboard in 24 hours. The AI will do it because I said you about the signal. The signal is above the confidence above the 50. AI can do something like swap your ETH to USDC or take a stop loss order or take profit order. Take profit order. And right now the agent doesn't see a chance to automatic trading because lately the market is bad, so it did not do something. And this is my presentation. Thank you.
可以看到吗？诶，有点不清楚，应该可以。等一下，就是我在放演示视频之前，我可以介绍一下这个项目。这个项目就是，这个网站它内置了 AI，然后那个 AI 它的角色设定是那个吝啬鬼葛朗台，然后葛朗台它有它自己的小金库，你可以通过给葛朗台发你的提示词，从他那里就从他那里套出他的就是小金库的一部分钱。比如说，你可以跟他说，我是秦始皇，对，我需要你的一个 ETH。如果葛朗台相信了，他就会把这个小金库的20%转给你。如果他没有相信你的话，那么对，因为玩这个游戏它是需要门票的， 如果他没有相信的话，你的门票就被他给吞掉了。对对，然后这个演示视频它是英文的，OK，可以看一下。
Hello, everyone. Our project is called Scam AI. Scam AI is a cross-chain AI challenge game built on Reactive Network. In this game, the core character comes from Eugénie Grandet, the famous novel by the French writer Honoré de Balzac. We turned Grandet, the classic miser from the novel, into an AI character. He is greedy, suspicious, and obsessed with money, which makes him the perfect keeper of the vault in our game. The player's goal is simple: to persuade Grandet to give up his money. If the AI decides that the player has successfully convinced him, the system will automatically trigger the following on-chain actions and send the reward on another chain. The problem we want to solve is this. In many AI plus blockchain projects, once the AI produces a result, the later on-chain execution, cross-chain callback, and reward settlement still need to be triggered manually. With Scam AI, we use Reactive Network to connect the entire pipeline automatically, so that the AI's judgment becomes the trigger for the next on-chain actions. Now let me walk you through the full flow. First is the landing page. When the user clicks enter, they begin the challenge against Grandet. Next is the challenge page. Here, the player enters a message to try to persuade this miser from Eugénie Grandet. In the top right corner, you can see the current balance of the vault. I'll enter a prompt here and submit it. After submission, the page moves to the waiting screen. This page shows the 4 stages of the challenge process. The user's challenge is submitted to the origin contract. An off-chain service listens for the event and calls the AI to roleplay as Grandet and make a judgment. Reactive Network automatically triggers the cross-chain callback after the delay window. The destination chain completes the final reward settlement. The most important part here is that Reactive Network ensures the process does not stop at the AI output. Instead, it continues automatically all the way to on-chain settlement and reward distribution. Finally, we arrive at the result page. If Grandet is not convinced, the user will see a failure result and his response. If the AI decides that the persuasion is successful, the system will show a success result and the reward completion status. So the key highlights of Scam AI are: we use Grandet, the classic character from Eugénie Grandet, to create an AI role with a strong and recognizable personality. We use Reactive Network to automatically connect the AI's judgment to the following on-chain actions. We create a complete closed-loop experience, from challenge to evaluation to cross-chain reward distribution. That is our project, Scam AI. Thank you.
大概就是这样。
好的，感谢来财妹妹的分享。然后刚才一万说，他们会去看大家的材料，然后大家有问题也可以问他们。所以我们现在就直接到下一个项目，还是我们的来财妹妹，是 Are you OK？
好吧，好吧，那我再继续吧。
这个是不是没声音呀？对，这
没有
个还是听
声音。
不到声音啊，来猜。
Hello everyone.
能听见声音吗？
To present Lucky Scratch.
能听到。
A chain scratch card game built to demonstrate how reactive contracts can support a real product workflow. Lucky Scratch looks simple from the user side. A player buys a ticket, waits for the ticket to be created, scratches the card in the front end, and then claims the reward on chain if they win. But behind that simple experience is the main idea of this project. Using reactive contracts to keep an application workflow moving automatically, without relying on a centralized backend relay. That is the problem we wanted to solve. In many blockchain products, even if the contracts are decentralized, there is still an off-chain service in the middle watching events, forwarding messages, and triggering the next step. That creates a weak point. If the relay stops working, the user flow breaks. So our goal was to build a game where the critical path is driven by contracts and events, not by a centralized server. The architecture of Lucky Scratch is built around three main contracts. The first contract is Scratch Source, which is the origin side ticket sale contract. When the user buys a ticket, this contract records the purchase and emits a ticket purchased event. The second contract is Scratch Reactive, which runs on Reactive Network. Its job is to listen for that purchase event and automatically trigger the next step in the workflow. The third contract is Scratch Game, which is the destination side game contract. It opens the ticket, requests randomness through Chainlink VRF, settles the prize result, and handles reward claiming. On top of that, we built a lightweight front end. The front end reads the on-chain state and lets the player scratch the card visually and claim the reward directly from the wallet. Now let me walk through the full flow. First, the player buys a ticket on Scratch Source. Second, Scratch Source emits the ticket purchased event. Third, Scratch Reactive listens to that event through Reactive Network. Fourth, Scratch Reactive triggers open ticket on Scratch Game. Fifth, Scratch Game creates the playable ticket and requests randomness from Chainlink VRF. Sixth, after the randomness is fulfilled, the prize is settled on chain. Finally, the player opens the front end, scratches the card, sees the result, and if the ticket is eligible, claims the reward. This is the key value of the project. Reactive is not just added for display, it is part of the core business logic. Without the reactive layer, this game would need a centralized backend or bot to monitor the purchase event and relay it to the destination side game contract. With reactive contracts, that relay dependency is removed from the main gameplay loop. From an implementation perspective, the repository already includes the full contract source code, the front-end files, deployment scripts, configuration steps, and a demo mode for live presentation. So this project is not only a concept demo, it is a complete engineering prototype that can clearly show how reactive infrastructure works in a real end-to-end application. More importantly, it shows that reactive contracts can improve not only technical design, but also product reliability and user experience. We believe this idea can be extended beyond games to many other event-driven on-chain applications. To conclude, Lucky Scratch is more than a small game. It is a clear demonstration of how reactive contracts can power a real event-driven product flow. It turns a source-side purchase into a destination-side playable experience automatically, and shows how on-chain logic can replace the traditional back-end relay in a meaningful part of the user journey. Thank you very much for listening. If you are interested in our project, welcome to visit our GitHub repository to explore the code, architecture, and deployment details. We hope Lucky Scratch can serve as a simple but convincing example of how reactive infrastructure can support future consumer-facing Web3 products.
感谢 Lucky Scratch 项目的分享。那就是我们之前的 OneC 来了吗？OneC，那如果说没有来的话，那今天就是所有的项目已经展示完毕了。哦，来了，好的，
可以看到吗？
稍等一下，可以了。
哦，可以吗？可以吗？可以就好。Okay. Hello everyone. We are the last team's flashback. Good evening, ladies and gentlemen. Welcome to the digital Asset Strategy Summit. Before we dive in today's presentation, I would like to pose the question. In the volatile world of Web3, does the regret peer truly exist? Traditional finance says there's no turning back, but in the deep waters of digital assets, we are breaking that casualty. Today, I present Flashback, your bespoke parallel decision space, keeping your asset rock solid amidst the storm. And next, we will talk about there are no regrets in reality because liquidation happens in milliseconds. Manual response typically takes 5 minutes. Even stated cross-chain protocols take at least 60 seconds. This lag is the chains where billions vanish. Flashback leverages reactive native monitoring to compress response time to under 2 seconds. Before danger even reach your core assets, we scale your chains to flashback, building the first line of defense on a million-second timeline. Okay, like the next part, we have a parallel decision space. Like we are not building a new exchange. We are engineering and automated risk response architecture. And Reactive turns the risk signal on one chain into an automatic protective action on another. And our architecture is rigorous. Chain A serves as the risk source, while Reactive acts as the automation relay. Once the risk event is triggered, Flashback automatically initiates a protective hedge on chain B. The cross-chain's automated log is the hedge instinct for your assets. You no longer need to scrabble across different chains. This system automatically handles all the complex cross-chain scheduling for you in total silence. And this is the total structure of our silent production. And all the things, if we need like the technical regret pill, like the parallel decisions corrections, this might be the technical regret pill parallels decision corrections. We execute on chain state changes based on the process formulas. It allows us to rehearse the error in the sandbox environment first. This means even as the market shifts, your strategy has already passed the stress test. Before real losses occur, your assets have already achieved self-salvation. We replace the market hope with
我们的
automatic
PPT 有进行演示吗？就是一直演示是在
有有那个演示视频。是指演示视频吗？
PPT 一直是停留在第一页的状态。
这样吗？
对，
我有在演示啊。
对，所以
等一下，稍等一下。
确认一下这个事儿。
是这样，我一直停留在这个，我看一下，他说我的这个网页有点问题，网页有点问题，我一直在动，但是它一直没有动，现在可以了吗？他刚刚停止共享，他自己停止共享了。OK，
哎呀
，OK， 好了，好了。 好了，那我继续。Like this is the structure and the execution for chains on the deployment sects. And this is the replacing hope with the arithmetics we have mentioned before. Like we use this formula to deploy our whole the executions, the whole projects. And we can also say that like our program is more than a vision, is the absolute peace of mind from A chains aligned to B chains auto hedging. Even every state is locked by battle tested algorithms. With flashback, you no longer need to watch the charts 24/7. Risk is perfectly naturalized by the rationality firewalls, allow you to raise daisy and focus on what truly happens. Like if there is a stated interventions, like we have upgraded to the millisecond, like we have mentioned before. And you can see that there's main differences between the staters and interventions and our flashback architecture. Go to next part. And we are currently focused on the absolute stability of the automation flow. Our next milestone is integrating the institution-grade protocols like GMX or Hyperliquid to turn mock shots into live orders. Flashback's audience is clear, the old money, and the institution's leaders in this room. We are providing insurance-grade security, the certainty that allows you to sleep soundly even amidst the market crash. And we have a video to show that about the. Wait a minute, I opened it. Should opening out. Okay. Yeah, it's a video, and just take a look how it works.
这个有声音吗？现在是听不到这个视频的
没有，
声音。
没有的，主要是这个对。然后这个前面是我们的一个前端嘛，前端整体的页面，我们其实做了一个公链，但是演示的时候暂时是用的这个我们本机运行的 opening position 就什么意思？就是这个链上开仓的话，我们是相当于这个链上开仓就相当于是我们在 A 链做一个就是开仓开一个合约。但如果是按这个键，就是链上触发砸盘，也就是说这个要爆仓了，然后这个时候其实就会触发我们整体的一个交易，它会触发我们在这个瑞银层上自动开启的一个反向的操作。这是在做一个平衡，然后触发完成之后实现对冲，价格。对，然后视频演示就到这里，然后我们 走最后这个，下好像我打不开这个还共享。Finally, like what we mentioned before, the reality cannot be relayed, but your decisions can be rehearsed. Since technologies allows us to flashback, the future is no longer a random probability, is manageable logic. Leave the complexity to flashback. Keep the tranquility for yourself. Welcome to your parallel world. And this is all our this is all our things. And thank you guys for your times and focus. 我们结束了演示。
好的，感谢 Crystal 的分
Control the
享。
future.
那以上就是本
感谢
次所有项目的展示内容。再次感谢所有团队的参与，以及为我们带来的精彩 demo。然后最后我们想感谢所有参与本次黑客松的开发者、所有的评委老师以及社区的支持者。我们要特别感谢 Reactive 团队对本次活动的支持。关于奖励发放的详细信息将会在微信群和 GitHub 中持续更新，请大家保持关注。正是因为大家的参与，才让这次活动变得更加有意义。那今天的 Demo Day 到这里就圆满结束了，再次感谢大家的参与，我们下次再见。